Alright, so we've covered measurement and conversion, so now we can kind of add the mole. And this is going to be really a foundational thing for us being able to add, basically take the mole and reactions and put them together to get stoichiometry, which is really the last of the big three, the biggest thing that we need to cover. So mole is kind of a foundational piece for that. So what is the mole? So chemical reactions can be read in terms of atoms, but this gets really unrealistic when we start talking about giant amounts. You know, if you think that like a palm full of water has somewhere around 1 times 10 to the 23rd molecules of water in it. And that's really not that much water. But it just, the amounts are unwieldy. Okay? So the mole was originally defined as the number of atoms in 12 grams of carbon. And it's known as Avogadro's number, 6.02 times 10 to the 23rd. And 1 mole of anything is 6.02 times 10 to the 23rd of that thing. So it's just another way of counting, like we say a dozen eggs is 12 eggs, or a ream of paper is 500 pieces of paper. Like it's just another way of saying something. So a mole of anything is 6.02 times 10 to the 23rd of that thing. A mole of paper clips would be that many paper clips. A mole of basketballs would be that many basketballs. By the way, a mole of basketballs would be somewhere around the size of the Earth. So, yeah, big number. All right, so we also need to know that because the mole is originally defined as 12 grams of carbon, that 1 mole of any element will have a mass equal to its atomic mass on the periodic table in grams. So that's an important and useful thing. All right, so mole conversions. So we're going to do conversions just like we did before, but we have 3 conversion factors when it comes to moles. First one is Avogadro's number, that 1 mole is 6.02 times 10 to the 23rd atoms or molecules. And I oftentimes just use the word particles just to distinguish, just atoms and molecules are in a bigger group called particles. 1 mole is equal to the molar mass, meaning the masses from the periodic table. And then the last one, don't have any, you're just going to have to trust me on this one, that 1 mole of any gas is 22.4 liters at what we call standard temperature and pressure, or STP, which is 0 degrees Celsius and 100 kilopascals of pressure, which is just a little bit below atmospheric pressure. Atmospheric pressure is 101 kilopascals. And so that's standard temperature and pressure. So 1 mole of oxygen, 1 mole of carbon dioxide, 1 mole of whatever gas you're talking about at 0 degrees Celsius and 100 kilopascals of pressure will take up 22.4 liters of volume. Okay. All right, so molar masses. This is one we need to work on a little bit. So we get these from the periodic table. So for example, chromium, the atomic mass or molar mass would be 52. Okay, so 1 mole of chromium would weigh 52 grams. The rounding rules I use for this is simply this. If the number behind the decimal is a 9 or a 0, just round it off and go with it. If it's something other than a 9 or a 0, then you need to include the decimal places, at least 1 if not 2. Okay. So we can also do this by adding things together. So for a compound, carbon dioxide, it's 1 carbon and 2 oxygen. So the mass of carbon is 12. The mass of oxygen is 16. And so 2 of those add together get you 44. Okay. So what about iron oxide? Iron 3 oxide, or rust. The oxygens are 16. The iron, notice, it's not a 9. So I need to include that decimal place. So 55.8 times 2, because there's 2 of them. 3 oxygens, so it gives me 159.6 as my molar mass. So you just simply take what you have on the periodic table and add them all together, and that's how you get the molar masses of compounds. Pretty straightforward and simple. Okay, let's look at some examples. So there's approximately 7 times 10 to the 22 stars in the universe. How many moles is this? Okay, so given over 1, do your units just like we've done them before, but we're going stars to moles, and it should have stars after it here. You need to tell me moles of what? So moles of stars. And so 1 mole of stars is 6.02 times 10 to the 1/3 stars, giving me 0.1 moles of stars. So let's look at another example. So how many moles are in a tablespoon of sugar, which weighs 12.60 grams? There's the formula for sugar, C12H22O11. So give it over 1. Then we get our units in the right place. Grams of sugar on bottom, moles of sugar on top. And then here we're using the molar mass because we're doing moles and grams. So using the periodic table, we figure out that the molar mass is 342 grams. And then we can simply do your math, put it in the calculator. You get 0.0368 moles of sugar. Okay? Now, that's one-step conversion. Sometimes we want to do two-step conversions. And that's where what we call the mole road comes into play. So we've got particles to moles, liters to moles, and so on. And so this shows us that if we want to convert from one measurement to another, we have to go through the mole. Okay? So if I want to go atoms to grams, I can't, there's no direct conversion. I have to go atoms to moles and then moles to grams. I have to do a multi-step conversion. Okay? Same thing with liters. If I know I've got 1,000 liters and I want to know how much it weighs, I got to go liters to moles and then moles to grams. And that's how we need to do these. All right, so let's look at an example of a multi-step problem. How many molecules of water in a single raindrop, which weighs 6.16 times 10 to the negative 5 grams? Okay, so I'm given 6.16 times 10 to the negative 5 grams. That needs to go on top. And then I need to get to molecules. According to the mole road, I have to go through moles. So it's going to be grams to moles, and then moles to molecules. Okay, and so that's going to look like this. Okay, so grams of water over 1, then grams to moles, moles to molecules. Final answer is molecules. Then put in your conversion factors. The molar mass of water is 18 grams per mole. Avogadro's number for the molecules, and you will get 2.06 times 10 to the 18 molecules of water in a single raindrop. Okay, that's over quadrillions of molecules in a single raindrop. Once again, it tells you how just crazy big the mole is. So work on your mole conversions. We're going to be using them in the next 2 lessons as well, just to get into this habit of using mole conversions. Essentially, the conversions are the same as what we've been doing. We're just learning 3 new conversion factors. And you do need to memorize them because you're going to be using them a lot. All right, so let's move into our next lesson right after this.